Right, so today we're going to finish up our material for the week with section 4.2, which is on congruence and triangles. Okay, what does it mean, or what do you think it means if we say two figures are congruent? Specifically, if we're going to talk about triangles, what do you think that means if we say two triangles are congruent? Yep.
That all their sides are the same?
Yep. So that's part of it. All their sides are the same measurements. And what else? Yep.
All their angles are equal to?
All their angles are also the same measurement. Yep. So they're exactly the same size and shape. So some examples of congruent shapes. Okay, here's two triangles. The angles are the sides are 3, 7, 5. And the angles are 50, 80, and 50. And those are basically just two copies of each other. Same shape. They are congruent. Okay, here's another example of congruent shapes. Okay, now in this case, one of them has been rotated. But to be congruent, they don't have to be in exactly the same position. Okay? They can be turned. Sometimes they can be flipped around. Okay? So congruent just means that the sides are the same length, the angles are the same measure. Okay, here's an example of shapes that are not congruent. Okay, clearly, a square and a triangle cannot be congruent. Okay. Next example here shows two shapes that are similar but not congruent. Okay. Similar basically the idea is that one might be a larger version of the other. Okay. But if that's the case, they're not congruent. Okay. Any questions on that? Okay. In this example, the bottom one here with the let's say quadrilateral, four-sided shape. What would be the same between both of them? Since they're similar, something would match up on each. Yep. The angles would all be the same. Okay? But that's why when we prove something congruent, it's more important to show the sides are the same, not the angles. Angles only prove that a shape is similar, not necessarily congruent. Okay, and when two figures are congruent, that means there's a correspondence between their sides and their angles. Such that the corresponding angles in each figure are congruent, and the corresponding sides in each figure are congruent. So this gets pretty picky with how we name things. Okay, we have to be consistent when we talk about congruent shapes. So if we're going to say that two triangles are congruent, it's very important that we list the vertices of the triangle in each shape the same way, okay, in the same order. And I'll show you an example. Okay, so here's two triangles that are congruent. Okay, how could you name the figure on the left? You could call it triangle, and then what would you name it?
ABC.
Okay, he said ABC. So if we're going to say that's congruent to the one on the right, we need to name the letters on the right in exactly the same order he did on the left. So he started with A, which is the one that connects the side with 1 tick mark and 3. So we'd have to start with X. Then he said B. That's the vertex where the sides with 3 and 2 come together. So look where 3 and 2 come together. And then C. That's the side where the 1 and the 2 tick mark sides come together. Now this one wasn't as bad because both triangles are drawn the same way. When you take something like the one on the right and you flip it and turn it, then it gets more confusing to make sure you name it consistently. Okay, so here's some other ways you could name it. You could do B, C, and then A. So if you name the one on the left triangle BCA, the one on the right would be Y, Z, X. You cannot switch that order. Okay? Once you pick the order on the left, the order on the right has to match it. Okay, how about, what if I did triangle CAB? And I said that is congruent to, what triangle would CAB be congruent to? Selena? Yep, ZXY. Has to be in that order. Any question on that? So this is what you call a congruent statement. You're saying two triangles are congruent. We've done these before with angles. Okay, we've done it with side lengths. Now we're doing it with a shape. Okay? So we say these two triangles are congruent. Okay, so that's what I just said. These are congruent statements because they tell you which two shapes are congruent. And if you list the letters correctly, I don't even need to look at the pictures to be able to tell you what's congruent. I can tell you that CA is congruent to ZX, AB is congruent to XY, and CB is congruent to ZY. All you have to do is match up the letters in the same spots, left to right. Okay, so that's called a congruence statement. Okay, below what I've done is I've listed all the angles that are corresponding and all the sides that are corresponding. Okay, so angle A corresponds to angle X, angle B corresponds to angle Y, and angle C corresponds to angle Z. All right, and the sides I just went through a second ago. So if I ask you to list all corresponding angles and corresponding sides, you should have 6 statements. 3 for angles, 3 for sides. Okay. Any questions on that? Okay, and as we go through, I'll try to help you getting that order correct because it can be tricky when the triangles are flipped around and reflected and rotated. It can be hard to figure out the right order sometimes. But for any triangle, does anyone know how many different ways can you name it? We did a couple here. We did like CAB, BCA. Anybody know how many total ways there would be to pick from? 21? No, not that many. It's basically a question of how many ways can you take 3 things and put them in different orders. There's 6. So for any triangle, if you take the letters A, B, C, there's 6 different ways to arrange them. ABC, BCA, and so on. So 6 different ways.
Don't you do that by doing like a fraction rate or something like that?
Oh, to figure out how many ways there are? Yeah. It's called a permutation. So there's 3 choices for the first letter. Yeah, you could pick an A, a B, or a C. And then after you make that choice, you only have 2 choices left for the next letter. And then after that, there's only 1 choice. And you multiply it. 3 times 2 times 1. Yep. So that's why there's 6 different ways. Okay, so first thing I want to do here is write a congruent statement. So that's triangle, then 3 letters is congruent to triangle, 3 more letters. And then I want to identify all the corresponding parts. So then that's 6 things. The 3 angles and the 3 sides. Yeah. All right, so let's start with the triangle on the left. Okay, the one on the left, you can pick the order pretty much anything you want. It's just once you pick that, the one on the right has to match. Okay, so what could we call the triangle on the left? Selena? Sure, triangle FED. Yep, that's fine. Now, when we name the triangle on the right, we got to name it in the same order she did on the left. So what corresponds with F? And this picture is, it's kind of flipped around a little bit. So Denver?
RST. Is it RST?
No, it's not RST. We got to look at the angle that would correspond to F. So F's got the 3 on it.
T.
T, yep, and then E has the single curve, S has the single curve, and then D has the 2, and R has the 2. So yep, FED is congruent to triangle TSR. Okay, now let's list our corresponding sides. Okay, Rose, can you give me one pair of corresponding sides? Okay, so she said D, E, so you went third, second.
Oh, wait, no.
Now you got to do the same. Yep, so RS. Okay, so she went the third one, the second one, third one, second one. Okay, so DE and RS. Okay, what's another pair? About Ariel? So let's make sure if we're going to start on the left-hand side, we use the left-hand triangle. So FE and TS. Yep. And there's one more. Anybody see the last one? Yep. Okay, so we've got EF. That's the same as FE. Which two? One more time. ED, we have that one as well. That's the same as DE. So we need the two letters we haven't put together yet. We've paired the D and the E, the F and the E, the F and the D. And that would be congruent to what? TR. Okay, and I scrolled the picture up off the screen on purpose because you should be able to just look at the congruence statement. You don't need the picture anymore once you write that congruence statement. Okay, so there's your corresponding sides and corresponding angles. Okay, let's start with angle F. Okay, angle F, Nathan, what does that correspond to?
The angle T.
Yep, first letter, first letter. Okay, another angle, let's do angle E. Okay, angle E. Dakota, what does that correspond to?
Angle S.
Yep, E is in the middle, S is in the middle. Okay, so you're just looking for that similar spot. Okay, and the last one, Morgan, which angle haven't we used yet? Yep, we haven't used D. And what does that correspond to? R. Good. Okay, so we've listed all our corresponding sides and angles, and we have our statement up above. Congruent statement. Okay. Any question on that? Okay, so this one a little bit more numeric. So we're mostly going to be sticking with triangles, but in this problem we're extending the idea of congruence to a four-sided shape. But we'll be going back to triangles in a minute. And I'm telling you that quadrilateral NPLM is congruent to EFGH. And I want to find the value of x. Okay, how would we do that? Well, let's find where is x. It's part of what? Yeah, segment GH. It has something to do with GH. So now we have to find the corresponding side in figure NPLM. Okay, what's the corresponding side to GH? Just look at the position in the correspondence statement.
LP.
No, not LP. LP would be GF. LP would go with GF. Yep.
PN.
PN would go with FE.
I can't tell.
Right? So you're looking at the position. First letter goes with first letter, second with second, third with third, fourth with fourth. So G is the third.
Oh, I was looking at the shape.
Yeah, you can't look at the shape. That's going to confuse you. The congruent statement's a lot easier. Yep. LM. Yep. Okay, so GH, those were the last two. They're going to correspond to the last two. It's very tough to figure out by looking at the picture sometimes. Okay, so now how do we use that? GH and LM are corresponding sides. What do we know about corresponding sides in this picture? They are, what's the word I'm looking for? They are congruent. Right? So we know that, let's just write it down. LM is congruent to GH. Okay, we'll now fill in what we know. Okay, how long is side LM? Yeah, it's 8. And how long is side GH? Yeah, 2x minus 3. So if the sides are corresponding, that means they're congruent. If they're congruent, they're the same length. Okay, now we solve that equation. So add 3 on each side, we get 11 equals 2x. Divide by 2. And there's our value for x. Okay, 5.5 or 11 halves. Okay. Any question on how we got x? Yes? Explain it? So we figured out x had something to do with side GH, because that's where the x is. So then we have to look in the other shape and find out what side corresponds to GH. To do that, we look at the congruence statement. G and H, third letter, fourth letter. Okay, go to our other diagram. Third letter, fourth letter, L, M. So now I know that LM corresponds to GH, which means they are congruent sides. Okay? And once they're congruent, then I just set their measures equal. Okay, now we're going to do the same thing. We're going to find the value of y. Okay, so let's go up. Okay, let's find where y is. Okay, Olivia, where's y? It's where n is. Oh, okay, yeah, that was going to be my next question. So E and N are corresponding angles. Yeah. So E, that's where the y is. So find the corresponding angle in the other shape. First letter, first letter. Okay, so E and N are corresponding angles. What does that mean? If E and N are corresponding, the angles are congruent. So set them equal. Take 7y plus 9 and set it equal to 72. Okay, and that's the hard part. Any question on how I set up that equation? I found the corresponding angles and set them equal. Okay, subtract 9. Subtract 9, we get 7y. 72 minus 9 is 63. Divide by 7. And what's 63 divided by 7? About Denver? 9. Yeah. Great. So we get y is 9. Great. Any question on that? Okay, so we could extend this kind of problem to a shape with as many sides as we want. As long as I give you a congruence statement, you should be able to solve it, matching up corresponding sides and angles. All right, so next theorem we're going to look at is, in the book, it's theorem 4.3. And it's almost a common sense idea that comes from the fact all the angles have to add up to 180. It says that if you have two angles in one triangle that are congruent to two angles in another triangle, then the third angles also have to be the same. They have to be congruent. Okay? Think if you had a triangle that had angles of 80 and 20, and then you had another triangle with an angle of 80 and 20. Well, if all the angles have to add up to 180, then the third angle must be the same in both of them because the other two angles were the same. Okay? That's the third angles theorem. Okay, so we're not going to go through a formal proof of that. Okay, maybe as a homework we'll do one, but it's really based on the idea that all the angles add up to 180. Okay, so what I want to do is find the value of x. Okay, let's see if we can make a congruence statement. They didn't ask for it here, but let's just see if we can write it down. Let's start with the triangle on the left. Okay, how could you name that triangle? Yeah, go ahead. Sure, we could call it triangle MNL. And I want to know what it would be congruent to. And what I would do is start by, M is a little bit tricky, but N has the two marks on it, so does R. L has the single mark, so does S. And if you can match those two up, then it only leaves one place for the third letter to go. So what would M, N, L go with? Kiara?
T-R-S.
Yes. What we just did is we just used the third angles theorem. We knew that N matched R. We know that L matches S. So if 2 out of 3 angles match, then M must match T. Okay, now how can we use the congruence statement to solve for x? How can we get x there? Yeah? Sure.
60 equals 2x plus 30.
Yeah. We know that angle M and angle T are corresponding angles. If they're corresponding angles in congruent figures, then their measures are the same. So the measure of angle M equals the measure of angle T. And when we solve it, we're going to get 30 equals 2x. So 2 times what would give me 30? Yeah, 15. Okay. Any question on that one? Okay, so just really use the third angles theorem. Okay. So I want to show, are these triangles congruent? What did we say earlier? What do we have to show for 2 triangles to be congruent? We have to show that what? Oh, Jacob? What do we have to show for 2 triangles to be congruent? Yep, we definitely have to show that. All their angles are the same. And what's the other thing we have to show, Brian?
The sides are the same.
All the sides are the same. Okay? At least that's how we're doing it right now. We'll talk more about that in a minute. Okay, but right now we're showing all the sides are the same and we're showing that all the angles are the same. Okay? So let's see if these triangles are congruent. Okay, let's look at side RP. That corresponds to which side? And be careful how you name it. You don't have to be as careful here as normal, but I would, because it'll help us later on. So I said R, then the P. Yep.
MN.
One more time?
MN.
Yes, M, then N. So I went towards the 92, M towards N, the 92. So segment RP is congruent to MN. Okay, good. We've shown one side is the same. Okay, so we have RP. Let's do PQ. Okay, does PQ correspond with anything? Marquise? Technically, that's good. I just want to make sure we name it in the same, trying to be consistent with the order. So we went from the 92 to the middle. So yeah, from the 92 to the middle. So NQ. Okay, good. So we got two sides matching. What else? We've got RP, we've got PQ, now we've got QR. Okay, which segment would QR match up with? Yeah, QM. Okay, so we've got all three sides matching up. That was given. Okay, so all of this was given. Let's see if our angles match up. Let's start with angle P. Okay, I already know that angle P matches up with angle N. How do I know that? That's given. But now nothing else is given. We've written down everything that was given. Is there any way I can show that another angle is congruent? Because really, all I need to do is show how many more angles are congruent. And then I'm good. Well, do I need to show two, or if I just show one more, then the third angles theorem says the other one has to be the same. So I just got to get one more angle. And then I can use the third angles theorem. Anybody see what other angles there would have to be congruent? It's not marked, so we got to use a theorem from earlier in the year. Yep?
The N and M, because of the exterior angle, they both add up to Q, or like the outside of Q.
Luke, that doesn't work. And can't be congruent.
So we got to, so you're talking about an exterior angle here?
Yeah, well, if you add angle N and angle M together, they have to add up to that alternate exterior angle or whatever.
So, yeah, so N and M, the two remote interior angles, do have to add up to an angle that's on the outside, angle RQN. But it doesn't help us, because that's an exterior angle. We need to prove something about an interior angle. But that is a true fact. I'm not sure how it directly would help us to prove. So how can we somehow prove, what kind of angles do we have in this picture?
Bunch of them.
We have a special relationship. We don't have a, linear pair, that's one type. We have special angles here. Yep. They could be acute. Certainly some of them have to be because we already have one obtuse. But looking for something else. Look at the kind of angles we have in that picture made by a certain shape. see something special happening in this picture, yeah? N, one more time?
NP and RM.
It has something to do with the segment NP and the segment RM, but it's more the angles created by their crossing. Type of angles. Yep. They're vertical, yes. Which can you tell me which two angles are vertical? You're going to need 3 letters to name the angle this time.
RQP.
RQP, yep. Let me write that down. And which other one?
NQ.
Yep, so let's see. Yep, we had R. That's where 1 and 3 come together. So then we have M. And then Q, that's the middle. And then N. Those are vertical angles. And we've already proven earlier on that vertical angles are automatically congruent. So now we've proven all 3 sides. We've proven 2 angles are congruent. The third angles automatically have to be because of the third angles theorem. So now we could say, what do we have? P, N, R, and M. That's the third angles theorem. So the original question, are the triangles congruent? Yes. The 3 sides are congruent. The 3 angles are congruent. Yes. Congruent. 3 angles are congruent. Okay, so we've shown it. Okay, any question on that? Okay, let's look at this one. So this one says you have 2 lines, 2 pairs of lines that are, we have AB and DC. Okay, those are parallel. And AB is congruent to DC. And they're telling you that E is the midpoint of BC and AD. Okay, this would be a tricky one if they didn't give you the picture. Okay, so I'm going to make sure if it's that tricky, I give you the picture. Okay, so there's your picture. Yeah?
Can you go back real quick? I need to get that back.
All right, so I've marked in the diagram AB and CD, or DC. Those are parallel. AB and DC are congruent. And E is the midpoint of the diagonals. Now, if we knew a little bit about a quadrilateral, having an opposite sides parallel and congruent, that means something. Okay? We don't need to know what kind of quadrilateral this is, though. Not for this. Maybe that's enough to prove it's a square. Maybe not. Okay, it depends. Okay, so I want you to prove triangle AEB and triangle DEC are congruent. Okay, so you need to show 6 things. Show that your sides match up, and show that all of your angles match up. Okay, let's start with the sides. Okay. The first thing I'm going to do is write down some of the information that was given. Okay, we know that AB is parallel to DC. Okay, AB is parallel to DC. Okay, and since something else was given, I'm going to put it in the same step. So I only have to write given once to start. Okay, AB is congruent to DC. Okay, given. You know what? Let's do the angles first. Okay, so now we've got those AB and DC are parallel. What kind of theorems can we use when we know we have parallel lines? Sometimes we have parallel lines that are cut by a what? Yep. A transversal. Okay, so that's how we want to think of this picture. Okay, parallel lines cut by a transversal. Anybody see some angles here that would be congruent because of the fact we have parallel lines, and those diagonals are like transversals. It's actually going to be two pairs here. Yep.
ABE
Angle ABE, sure.
is congruent to ECD.
Okay, so ABE, so he said this one is congruent to ECD, yes. Okay, and that's alternate interior angles. Okay, what else? We can say another thing in the same statement, and it's going to be the same reason. So I'm going to list it right here as well, just having to do with two other angles. Yep.
Angle AEB be congruent to CED.
Yes, that one will be congruent. That's going to be a different reason, though. Those are going to be your vertical.
Then it's going to be CDE is congruent to EAB.
Yep, so angle CED. And then what was the other angle you said?
EAB.
EAB. Yep. Again, two parallel lines cut by a transversal, alternate interior angles are equal. So EAB. Is that the theorem or is that the converse? Yep.
Theorem.
That's just the theorem without the word converse. So alternate interior, oops, interior angles theorem. All right, so now we've got those angles, and we already said the third angle. Luke, what did you say the third angles were?
AE.
Yeah, let me go back up.
AEB is congruent to CED.
Yep, AEB is congruent to CED. And what was the reason for that?
Because they're not vertical.
Yep, so vertical angles. Right, so we've proven all the angles are congruent. Okay, we can mark those if we want. Okay, so all the angles match. Right, now we got to get the sides to match. Well, I already know two of the sides match. Right? AB, okay, matches up with DC. Okay, that's given, and I already said it. Okay, so we've got that one. Now the other sides. What about? Let me just write this so you can see it again. This was point E. How can we use this midpoint fact? We haven't used that yet. Think about what it means to be the definition of a midpoint. E is right in the middle of segment CB. So what would that mean? E is right in the middle. Denver? Yep, CE and EB are congruent. That's the definition of a midpoint. CE and EB. Okay, let's go back up. How about looking at on the other diagonal? Looking at diagonal AD. E is the midpoint of that as well. So what does that mean?
AE is congruent to ED.
Yep, AE and ED. Okay, we're not naming them in exactly the same order. We went from 2 to 3. We could go from 2 to 3, so DE, but that's okay. So AE is congruent to ED. It's congruent to ED. And that's the definition of a midpoint. Definition of midpoint. So let's go back up and label what we have now. So this side matches that side. This side matches that side. So we've proven that all three sides are the same, all three angles are the same. We've proven that these are congruent by the definition of congruent triangles. Okay, so let's see if we can write it. How did they do it? Triangle AEB and DEC. Triangle AEB is congruent to DEC. And the reason, that's the definition of congruent triangles. Okay, so you can abbreviate it just like that. Hey, any questions on what we did there? Okay, now the way we just did that is fine. Okay, it proves that the triangles are congruent. Proving all the sides are the same, proving all the angles are the same. But there's a much better way to do that. Okay, so in future lessons, we're going to do this more efficiently. Okay, we're not going to have to prove all the angles are the same and all the sides are the same. If you just show all the sides are the same, that's enough. That works. Or if you show like a side, an angle, and a side, that works. Or if you show two angles and a side. There's all kinds of combinations of things you can show, but you do not need to show all six. In this lesson we are, but in the future we're going to come up with a faster way of doing it, just showing some of it. Okay, but if you can do all of it, then when we only do a little bit, it's easier. All right, and the last thing we're going to look at is Theorem 4.4, okay, which is some properties of congruent triangles. We've already seen all these properties before. We're just doing them with triangles. Okay, so the reflexive property. Reflexive means that something is congruent to itself, or something equals itself. Okay. So with a triangle, reflexive property means every triangle is congruent to itself. Triangle ABC is congruent to triangle ABC. Okay. Anybody remember, what's the next property we usually do? There's three of them. There's the reflexive, the transitive, we're going to do that, and then there's one more. Symmetric. Very good. Okay, so the symmetric property allows you to switch what's on each side. So if triangle ABC is congruent to triangle DEF, then it's also true the other way. Triangle DEF is congruent to triangle ABC. And the last one is your transitive property, okay, for congruent triangles. Anybody think they could give me an example, like explain what the transitive property is kind of in general? And then we'll do it with a triangle. We've done the transitive property with parallel lines. We did it with angles. We did it with segments. It's going to be the same thing. Just what's the general idea of a transitive property? Luke?
If like x equals y and y equals z, then x is equal to z.
Exactly, yep. So it's when you have that chain of things, and then the first one and the last one are equal. We're going to do the same thing with triangles. Okay, so if triangle ABC is congruent to triangle DEF, and then triangle DEF is congruent to triangle JKL, what would that mean? What would be the conclusion here?
Triangle ABC is congruent to triangle JKL.
Yes. Triangle ABC is congruent to triangle JKL. Good. Okay, so we see the symmetric, reflexive, and transitive properties. We see them over and over. Now we're just doing them with triangles. Okay, so again, as a reminder, your test tomorrow will cover everything from section 3.7, 4.1, and 4.2. Okay, so the homework, it's on 206, 10 to 19 all, 25, 27 to 29 all, 34 and 35. And we did all the multiple choice for MCAS, so we'll just do the open response. And we'll go over that before the test tomorrow.